So to doing the calculations associated with this little gasoline engine that we got going is basically three parts. It's the compression, and the main part of that calculation is to compute the temperature at the next state, from the starting point, to predict the temperature and then the work of compression. And then part two is the actual combustion process, and the main part of that is to predict the adiabatic flame temperature, and then to get correctly the species that you have as products of combustion in terms of mole fractions and mole numbers. And then part three is the expansion, where you need to predict the temperature at the conclusion of the expansion, as well as the work of the expansion. So those three parts, you need to get them right one at a time in order, okay? And so that would correspond to homeworks AA, B, and C respectively. But I just have it all as one homework now that is due, I believe it is on the Wednesday when we come back from Thanksgiving, right? That's when it's due. And that would allow you to foul it up and have a retry on it. I can get it back to you the next Monday, and we should be working on it. If you don't have the numbers, the sample numbers I'm going to give you, you should know that it's fouled up and be able to continue working on it. And the retry is going to be due on the last day of class. When you get homework 8 working, the final exam is just to exercise that program for variable fuel-air ratios and variable compression ratios, and do some plots. So the final exam is really a freebie if you get homework 8 working, okay? So part 1 of homework 8 is to basically give me the temperature, the pressure, and the work of compression for this process, given the same conditions on inflow as the course notes, okay? And I want you to please do it for a rich mixture, Y over YCC of 0.7, a stoichiometrically correct mixture, which is Y over YCC of 1, and then a lean mixture, Y over YCC 1.4. So the case of 1, oh, and by the way, it's for a compression ratio. All of homework 8 is for this compression ratio of 5. So the numbers that you get for Y over YCC equal to 1 are the exact results of the notes. Okay? You will have those in there. Okay? And if you program up everything as variable with respect to Y, then you can just change Y and do it these other cases. Okay? And your exam is going to have you look at these performance criteria of power, fuel consumption, and thermal efficiency. You're going to look at it as a function of the richness of your fuel-air mixture, and also as a function of your compression ratio. So you want these things put in as variables that you can change and put in terms of a do loop, okay, and have it automated, okay, and run through a bunch of these things automatically. This is just a way of getting your final exam working right, okay? So if you programmed it up right, you get Y over YCC equal to 1 working correct. The other 2 should work. I find sometimes they don't, okay? You'll have your adiabatic flame temperature for your lean mixture won't run right for some reason. Okay, you won't have your species right after combustion or something for a rich or a lean mixture. See, a lot of stuff for Y over YCC equals 1, there's stuff that goes to 0. And so if you have it 0, you get it right for that one. But when it's not 0, people will have something wrong, okay? So this is a way to check on both. It's a way for you to look right at the value that I have in one particular case, and then look on either side of the richness of your fuel-air mixture, richness meaning know, how much fuel you have there versus there, okay? So in this case, give me T2, and this is what you have to solve your second law iteratively for T2. P2 just comes from your ideal gas law, it's easy. And then your work comes from solving explicitly your first law. So give me these three things for those three cases. That's part one. Part two deals with the combustion, okay? And what I want you to give me, please, is your adiabatic flame temperature T3, then from your ideal gas law, P3, but your mole numbers have changed, so you have to be careful. You don't have like a fixed mole numbers version of your ideal gas law where you can just equate that and have it drop out. You have to account for the fact that the in total for your fuel air mixture is different than in total for your products of combustion mixture. So be careful with that. And also tell me what your mole numbers and your mole fractions are. Okay? We all know or should know what in total is for the reactants. That's actually not going to change for any of these Y's. But for the products, it'll have a slightly different value for these different Y's. So you need to give me the in total for the products. And these values right here, you have for Y over YCC equal to 1, you have rough values here that you should match me exactly. Okay? And then the final part of this homework assignment is this is the expansion. And, whoops, went the wrong way. That's back to the compression. Please give me the final temperature after the expansion. That comes from solving your second law of thermodynamics, making your change in S 0 from the starting part of your expansion to the end. You find T4, and then from your ideal gas law you find P4, and then by solving the explicitly an equation of your first law you can get your work, okay? And these are the quantities you need, after which, once you have them, they're easy to put together and do your final exam, okay? So that's homework 8, and that's going to be due on Wednesday when we come back, if I remember correctly. And then I'll have a Wednesday for your retry. And then I told you your final exam, which I'll go over here, you can give it to me anytime early, but the due date is going to be Friday, Friday, December 7th. It's 2 days after the last day of class. Friday, December 7th at 12 noon. You can give it to me personally beforehand, or you can put it in my mailbox, which I've taken out of shelf, so I'm going to have another class doing this too, so you're going to be competing with Advanced Thermo for space in my mailbox. And then Ms. Diane Mitchell in room 241A knows that you all might be coming to her and giving them to her. Okay, so those are all acceptable ways to turn it in. Okay, at 12 noon, it's late. All right, y'all got that? I've documented this on Blackboard. Okay, the final exam. And then final exam is not here with the homework. I don't think I actually have it here, darn it. I could go on to, guess I could go on to Blackboard and look at it. Let me do that. Bring that thing down. Hard drive with me in the other class, but I left it in my office. Let me, let's see here. Are they requiring you all to do the two-factor identification thing? Yeah. I don't think I'm gonna be able to log on because I have a two-factor identification that uses my smartphone. Oh, they want me to do a bunch of other nonsense. Okay. Don't have it here with me. The final exam is not with the homework. It's under the general heading exams, okay? And it will be these handwritten instructions on what I want you to do, okay? And what I'm going to want you to do is to compute your power in kilowatts exactly like we did in the course notes. One of the results I'm asking for is exactly one of the ones in the course notes. Your power, your thermal efficiency, and your specific fuel consumption. Those three things is a function of Y over YCC. And I think I take it from something like 0.7 to 1.4 in increments of 0.1. And you plot those things, okay? And then for Y over YCC equals 1, I want you to tell me what those same output functions are as a function of compression ratio, where you go from something like compression ratio of like, just say 6 to 12 in increments of 1 or something like that, all right? Just like that. So that's what you do, and the next time I come, I will come with my, either my cell phone for logging in or my disk, and we can actually look at it. On Blackboard, I believe it's under assignments, under homework solutions. You remember the non-computer programs, homework assignments, homework 1, 2, 4, and 4. Remember there were solutions.
Yeah.
Okay, what I have now, I believe it's there under homework solutions. You'll find this file that says sample results for homework 8, and that also applies to the final exam, where for Y over, for a compression ratio of 9, and Y over YCC equal to 0.7, 1, and 1.4, the exact ones of the homework 8 assignment. I tell you what the important temperatures and works and all the things you have to compute are. And then I tell you what the power, the specific fuel consumption, and the thermal efficiencies, I tell you what they are also. So that you'll also have numbers that to spot check with what you have to do on the final exam, okay? So everybody has every opportunity to spot check everything and get it right. It's a gift, okay? So when your computer programs give my numbers, you have it right. And if you don't give my numbers, you have an error. I'm sure of it, okay? Don't even think for a minute it's my error in this case, it's yours, okay? Okay, I mean, there's certain things you just know, okay? I'm wrong a lot, but not on the numbers I put out there, okay? So, you can be confident in those numbers. Does anybody have any questions about that so far? Okay. Mr. Frederick, are you here? Mr. Will Pegram, are you here? Mr. McGuire, are you here? Mr. Riad, are you here? Mr. Corby, are you here? Mr. Hewitt is not here.
I was a chump.
Mr. McGuire?